All right, welcome, ladies and gentlemen, to week number 58. My name is Brian McLogan, and this is Open Live Q&A. And in this week's video, what I want to do is kind of talk to you a little bit more about some short form content and some of the things that I am looking into doing on my channel, as well as just kind of like getting some kind of the feedback, from you guys that have, kind of grown into this short form, kind of content, and see that how is that going to kind of integrate into like learning math. And I know it kind of might seem a little bit odd, but I think there's a lot of connection that we've a lot of connection before, as far as getting things like short and to the point, and obviously with and then also with some learning. And one of the things that I've been working on in my channel is creating some shorter form content in addition to definitely some longer form content that gets a little bit deeper. And Venextorian, thank you so much for joining in on as a YouTube member. I would like to let you guys know that tonight's live stream is supported by my memberships on YouTube. And I do really greatly appreciate all of you guys supporting me on YouTube. And that means if you are a YouTube member, that means if you are watching my videos or showing up on these live streams, I really do appreciate all of you. And I see you, Addie and Kelsey and Sinai and Nick and Manu and Kyle B. Thank you so much, guys, for joining in. We have a lot of questions that we are going to get into. But some of the things that I asked on my live stream that I forgot to post in here. I forgot to make a copy. So since I forgot to go and do it, but just kind of let me know. I want to see for you guys that are on this stream, where do you kind of enjoy as far as short form content up to this point? There's, as far as I'm considering, like as far as what I watch is YouTube Shorts, Instagram Reels, or TikTok. Like, where do you see yourself spending some time? So feel free to add any on what maybe you prefer, and not so much where you're going to want to watch math videos, but where do you just kind of prefer like spending your time? Just going to kind of see what you guys are kind of thinking, because I can tell you from the vibe that I get as a teacher, I know where my students are spending, most of their time. But obviously you guys are much more diverse than inside of my classroom, from all over the world, all ages and ethnicities. So I want to kind of see where you guys are kind of standing with all that. All right. I'm seeing a lot with TikTok, and yes, I would agree. It was kind of funny when I looked at I'm going to actually pull this up real quick because I forgot to do it before. When I was looking on YouTube, and I did my poll, which I'll go and do. Definitely some TikToks and YouTube thoughts on Super Bowl. I'll get to the Super Bowl in just a second, but it was definitely kind of interesting because I did not expect to see so many people on YouTube Shorts, and I know YouTube is definitely making a push, and I think there's going to be more to come on the YouTube Shorts. But it was just kind of interesting watching and seeing what so many students. I mean, I think it was like 60 or 70% of people were saying that they preferred the YouTube Shorts kind of platform, because right now it hasn't really been drawn out. So yeah, I haven't gone through all the comments yet, but I'll go and post a little screenshot here. At least you guys. For those of you that were on my community tab, and typically each and every week I'll either do some kind of question or a poll for those of you guys to kind of interact before we go live. And I'll go ahead and post that right here. And you guys can see, yeah. So as I posted this yesterday, roughly, I don't know, like around 11 a.m. So it's been a little bit more than 24 hours now. And you can see like YouTube Shorts is kind of taken off. So kind of a little interesting, because I feel like a lot of my students are definitely much more into TikTok at the moment. And I don't think YouTube has really put their full weight behind Shorts yet. And I think Instagram Reels is just really kind of still feeling where they're going to get their placement and everything. So kind of interesting to kind of see where everything has been going, where everything is right now, and then also where it's going to. And one of the things I want to talk to you about is I really feel like short form content is really going to be the much more, into the future of where a lot of educational content is, and really just digestible content is going to go. Obviously, I think always, there's always going to be a benefit for longer form content, where we go really deep into something. But I think back in when I started my YouTube channel, one of the things that I wanted to do was create short math videos. And the reason why was because if I was going to learn math, I didn't want to watch a 10 or 20 minute video. Like literally I would see a video and I'd be like, nope, not watching this. And so that's really how my channel really started. It was like, I just want to make as many videos as possible showing you exactly what you need to know on this video. And majority of my videos on my YouTube channel, 11,000 of them, are less than like 3 minutes long. So, that was just how I kind of figured that it would be the easiest and fastest to digest the information. Now, obviously, the more you go up in your mathematics, the more difficult, and the more kind of thorough you want your explanations to be. So obviously, I have some longer form videos, and obviously, even on my channel, I've done some videos that are very, very long, just to kind of make sure that students really get the full explanation. But I think for a lot of students, and just for a lot of learning experience, being able to provide something that is exactly what that student kind of needs to know is something that I think is going to continue to grow. And also, as I've kind of seen from watching TikToks and shorts and, Instagram as well on myself, like I think when the first time Vine came out, I remember I was like, man, these videos are just so short, like too short, but I think that we've gotten so much better now of, editing and creating content to be able to provide you this like great experience in such a short form that our appetite has really kind of changed. And I think that, under the minute is really something that is doable for a lot of content. Even that's something that we might not have been able to look into, be able to think we would be able to explain or do previously is really kind of is capable now. The other thing I wanted to bring to you guys is, so I have been experimenting on TikTok. If you have not followed me, Brian McLogan, I'm on TikTok playing around with some things. There's a lot of things I want to be coming down the pipeline. At right now, my capacity for doing more math videos or doing more social media has just been like so limited. But I have been playing with some TikTok videos. I have been playing with some YouTube shorts. And also some Instagram reels. So slowly but surely, I'm just kind of testing the waters. I like hearing what you guys are, where you guys are at. But also I like seeing the, what kind of actually what people, how they respond to things too. Right. So that's some of the things that we'll look at the data, going in from there. And so, but yeah, I wanted to kind of see where you guys were, playing around, where you guys like digest a lot of the information. And then, I'll let you guys know where, as I'm kind of putting some videos out there and improving my game, let you kind of know where I'm starting to get some of the feedback and the analytics and where some of the things are working. I do some shorts on my YouTube channel, and then I also created a new YouTube channel, as well to kind of post some shorts and just kind of get some unbiased, analytics and kind of see how that was going to go. And thank you so much, Tyler, for your super chat. I greatly appreciate that. That is very, very nice of you. And I'm so happy my video has been all help. So awesome. Thank you so much for that. Engineering classes. Well, that's awesome, Tyler. I'm so happy for that. It's awesome. Congrats to you and keep working hard. I like your short videos because you explain math really well in short. Yeah, I think that's, kind of the name of the game. Karen says, are you a football fan? I am a football fan. I am watching the Super Bowl. And I remember last year, being in the same position. It was like, typically I'd usually be spending my time watching the Super Bowl or at a Super Bowl party. Obviously with COVID, that's a little bit different now, but yeah, no, I am a football fan. I'm not as much of a fan of where football is kind of headed or has gone in the last, I don't know, say 5-10 years. But I still do enjoy, watching football, at least the sport of it. But I think with, college and pros, it's just kind of, I don't know. I think with a lot of the, a lot with the the regulation, the rules, which for a good reason and good purpose. But it's very gotten like bogged down, and it takes for too long, too many penalties, too much time, too much replays. And it's like I just want to watch action, right? And so those are kind of some of my issues I've had with football, and that goes across all sports or a lot of sports, not just football. But some of the things that I really enjoy, like rugby or hockey, that just kind of has that more continuous action, and you just get to like watch a good game. And I think that football is just kind of lost. I still enjoy it and I still watch it, but where it used to be, I'd feel really bad if I missed a game, and I'm like, I'd be very upset if I missed, a game on a Saturday or Sunday. And now I'm just like, I can watch the highlights and probably get my football fix, from there. I'm not as, obviously, if there's like a great ending in tonight's game, like I'll probably want to make sure like to rewatch it and, kind of see from there. But besides that, I've kind of got my football fix. I don't think there's too much that really like, I feel that I'm always missing out on, so football is just tackling each other. Well, yeah, there's a lot that goes into the game. I played football, when I was growing up and in high school, and I really enjoyed the sport. Like I really did, like the sport, but yeah, I think, it's just like watching it, or at least going to the games. It would, when it used to be something that I would enjoy or look forward to, it's not something that to me is really brings the experience. And I know for some people it does, and that's awesome. But for me, I think a lot of it has changed in the last couple of years, that it just hasn't really been as important. And obviously, times and responsibilities change for whatever else. What about golf? I think it's really exciting. Yeah, golf. I enjoy golf too. I'm not as much of a fan of golf just because I'm not as good at golf. And golf is one of those, things that you gotta put your time into, just kind of like mathematics, actually, but yeah, I think when you put your time into something and you get good at it, it's kind of amazing how that kind of works. But it's like anything else. I play baseball as well too. And a lot of people are like, I hate baseball. It's so slow. You don't understand. And I'm like, when you don't play like a sport like golf or baseball, and you don't understand what the players are going through, you just see them like hitting a shot or, hitting a pitch, and you just don't understand the difficulty and the beauty of what's actually going on in the sport. So I think that's true for a lot of the sports, even that I, have not played or I'm not very good at and have not a lot of experience in, but I think when you play different sports or you have experience with other sports, and you really see the amount of skill and attention and practice that so many of these athletes go into, that it's really just, amazing. And like, you can watch them on TV and be like, oh, this is boring. And, they're just swimming, that's it. And it's like, but you see what they accomplish, and especially if you have some sort of an interest, or not an interest, but an experience of like what they've gone through or what they're doing, I think it brings it to a different level. And that's why I enjoy baseball and even golf, because I play both sports, right? Or I played at least both sports. So I can definitely appreciate a lot what goes on with those sports, and I can watch the game for that kind of appreciation and that love for the game. So why are rational expressions hard? Because they're fractions. That's why they're hard. Well, Abel was a good G. Well, thank you so much for that super chat. I greatly appreciate it. I am doing well. Doing some math tutoring on a Super Bowl Sunday. This is definitely something that is not what I would be thinking I'd be doing if you were to ask me years and years and years ago, of when I'd be going to like some Super Bowl parties and everything else. Melinda says he played golf. Yeah, I guess you could say kind of. I guess my one thing with playing golf was I'm a baseball player. Like I played baseball like basically my whole life. So I kind of have that hip problem where my hips just love to rotate very, very much. And it's very difficult for me to unlearn that. So that has been my antithesis, or just kind of my nemesis with my golf swing. chess and cricket. You can definitely see it. People are like, I can't watch chess. Well, I'm like, if you understand chess and you appreciate what all they're going through, like you can definitely, like you can definitely watch it and see everything. How much money do you give up teaching pre-calculus? I don't know. Math at Harvard, I spend most of my time on. Yeah, I can definitely see that, Jace. Well, hey, spaghetti guy. Procrastination tips. I think, Abigail, I don't know if I have a good procrastination tip. I was trying to think of actually a good quote before I get into my problems, which I should probably get into rather soon. But there's a good quote on procrastination, on I think understanding why you're procrastinating. And, I think sometimes when you put things into perspective of why you are making the decision to not do something, sometimes that just makes you like realize like, hey, I got to get this done, and like, I don't want to do it. Or maybe I don't have to do it right now, but it's like, I need to, I think when you understand the purpose and the reason of why you're procrastinating or why you're avoiding taking some action, there's a really good quote that puts this in perspective, but I can't think of it at the moment. But I just maybe just call yourself out on it. List the things of why you're not doing it. Why, what are going to be the consequences, and and put things into motion. I think a lot of times we procrastinate because of maybe the unknown, or we I don't know, the unknown, or yeah, just even the thought of like just not wanting to get it done. And I think the idea of understanding that and just taking that step forward and getting the motion in there can sometimes help you out. But yeah, procrastination is something I deal with as well. Like, I mean, there's a lot of times that, like, grading, I hate grading, right? I've done a live stream on many of that times, and like sometimes I'm just like, I have to get grading done as soon as possible, because if I don't, I just cannot stand grading. I mean, it's very bad when I sometimes will procrastinate and just pushing grading off. And then it's like on Sunday night, I'm like, all right, guys, I'm done with my live stream. I got to grade, and I'll stay up for another like hour or two grading for tomorrow, for the next test. So I definitely understand and get you with that. Yeah. So then you have to watch it. Yeah, it's no, I am not a robot. I see you deleting these messages. All right. Let's see if there's anything else going through there. Well, hey, Melanie, thank you so much for that. You are very welcome, Adam. And who do you got for the Super Bowl? Well, I am originally from Michigan, so if it's not a team from Michigan, which obviously the Detroit Lions are not in the Super Bowl and probably not going to the Super Bowl anytime soon. But hey, don't want to say that out of my mouth because you never know with the Lions. Then I'd say my second team would obviously be Jacksonville, which is obviously where I currently reside. And if it's not going to be from Jacksonville, then I'd say a team from Florida. So I got to take the Tampa Bay. So hoping and rooting for. Does anybody have a update? I don't want to go into the. I don't want to open up another link and go and check on the score. But let me know, somebody in the chat. Let me know how that goes, because I do like to follow. I did watch a little bit of the game before my daughters got a little bit upset with me and wanted to watch something else. Yes, Tom Brady did go to University of Michigan, and I think I was in high school when he was in the University of Michigan. I believe so. Yeah. So I grew up just outside of the University of Michigan. So very, very, very much remember when he was there. And England going to win the fastball game. Not really sure, but I know Scotland beat England in the Six Nations. So that was going on. And that happened today as well. I didn't get to watch that game either, but had to make some videos for tonight. So, all right, guys, let's, yeah, somebody, 9:31. Oh, Tampa just keeps on adding to the score. Not tell him. It's so nice to see you good at teaching about. Well, thank you so much for that. Hey, can you go over two sub equations? Oh, let's go over some things. So thank you so much, guys, for all of your questions. I did get a lot. Dalton, I teach everything, Algebra 2, Geometry, and Pre-Calculus. So I have all the grades. And hey, well, thank you so much for another super chat. I greatly appreciate it. You are awesome. My favorite right now. Thank you so much. Again, I really appreciate that. So I have a lot of questions for tonight. That's why I was like, man, I should probably actually start. Oh, I have 13. No, I got 18. Whew, okay. Yeah, 18. All right, guys. So a couple things just to note for those of you that are on and ready to go. If you are interested in submitting a question for my live stream, these are all been pre-submitted. So from last week, these have all been pre-submitted. A lot of times I do like to take questions from the chat, but that typically is just kind of like time sensitive. If I have time, I'll go ahead and do it. I like to add in sometimes. This time I had over, I think 60 questions that were submitted for tonight's live stream. And I was like, all right, I just need to get these, get as many done as possible. We're not going to have as lot of, inserts, for me to be able to do some extra questions. So a couple things just to let you guys know of, submitting like word problems where we have to like describe a paragraph before we can get to the question is not a very good live stream question, just because it takes so long for us to like understand the question and then write the question and then work through a question. The same thing, a lot of students submitted very vague questions. I didn't really understand what they wanted me to do or help them out with. Or they would submit like 5 or 6 problems that they wanted me to do. So you guys can see, obviously in this case, I'm basically just been able to, I want to be able to get through as many different types of question as possible. So your ability to be able to submit questions, or at least one question, and be kind of descriptive in what you're needing help with is very helpful. And also more likely for me to be able to get to your question. And obviously, guys, there's a lot of math that, when I have like 60 questions to go through within an hour, a lot of times I don't have time to really think too much about the question. So if it's something that I'm like, oh yeah, I know exactly how I'm going to explain this or what I'm going to do, then I'll obviously go and add it. And if it's something I'm like, crap, I need to like think about this, or maybe I need to like look up some information. For tonight, I just didn't have that time. So there's a lot of questions that I'm like, this is a good question. I like this question, but I would need to like look up some things or just kind of think about it a little bit more before I got into it. And unfortunately, I just didn't have the time to do that. But I do see you, Abraham and Abel. Thank you so much again for your super chat. You guys are very, very awesome. And thank you so much. I really, really do appreciate it. Thanks for doing. So I think all these questions have been pre-submitted. So if you guys aren't interested in adding a question to my live stream, I'm not going to be able to add any more for tonight. Maybe we'll see how quickly I go through these questions, if I'll be able to answer some questions after the stream. I will be doing I do have my member stream though afterwards that I will just kind of go through. And that's part of anybody that is a YouTube member. What I have from that case is on the YouTube membership, the students are able to, I just kind of do like another private stream afterwards, just to kind of like calm down, because a lot of times when I go to these streams, I get so excited. It's kind of weird to say excited, but yeah, the adrenaline is just kind of rushing through me, and I just need to like calm down. So I do an extra live stream for the YouTube members after the stream, and where I just kind of like relax on my own. And then obviously if they have any questions, I'm happy to answer them. And Abel, thank you so much. You are awesome. And Edson, thank you so much for the super chat. I really, really do appreciate it. I have 100,000 on TikTok. Add me. Well, I guess I'll have to go ahead and add you back over there. There are some people that are asking me about the tutoring. That is something I have the ability, or something I've been looking into doing. I've just been so busy. I haven't been able to open that up. So as of right now, I'm only offering the tutoring to the YouTube members. They don't know yet, but that's something that I am going to open up to them. And but yeah, and then that's hopefully something after I kind of get the wrinkles out from that kind of process, then that's something I'll open up to my channel. But obviously I have a lot of limited time for me to be doing private tutoring. So that's something I'm trying to work through, and like how I'm going to deliver that and everything else. Silhouette, I do Not going to be answering any other additional questions, at least on this time, but if you do have questions on your definite integrals, feel free to go ahead and check out the link, and therefore you guys can submit your questions for the next live stream. And then each and every week after I have completed live stream, you guys can go ahead and check the description, and I do timestamp all of the questions for you guys to go ahead and take a look at. So, all right, guys. Well, without further ado, I got to get into some math because otherwise we're going to be on the stream for way too long. All right. Ethical, if you go to the YouTube platform, you can, I believe, just join as a YouTube member from there. Okay, so let's go ahead and get started. So question number one, I can't remember who submitted this, but I think they were just asking for factoring. Okay, so if I want to factor when a is not equal to 1, I think the main thing that I want students to recognize from this is that all your quadratic trinomials can be factored or written as a product of two binomials. Now, the next thing is when we have a negative, or our last number is negative, that means we're finding the difference of our two products. All right. Now, if my last number is 1, then we basically have 1 and 1. Right? Now, if it's going to be negative, that means one of them is negative, right? So -1, +1, or +1, -1. It doesn't really matter. But the point that I want to make to you is these last two numbers, these two give me 2x squared, and these two are going to give me x. And actually, you know what? Let's do it this way. 2x times x is 2x squared, and 1 times 1 is 1. Now, again, this needs to be negative. So that means one of them needs to be negative, and one of them needs to be positive. Now, there is only two options, right? It's like flipping a coin. So how do you know which one is which? Well, the difference, right, is when you're looking for, when this is a negative, obviously you know that one term is going to be negative, one term is going to be positive, but also it tells you is to find the difference between these two products. So the difference between the two products, of the inner and the outer. So I say 1x and 2x. Well, that has a difference of x, obviously. And if we want them to be a positive, then we want the larger product to be positive and the smaller product to be negative. And that's why that's a -1, and that one, it's a positive one. Now over here, we can kind of do the same thing. It kind of gets a little bit more difficult though, because if we see this is a positive, right? So you can say, well, Mr. McClellan, I don't know. Is this a 3x and a 2x? Or is this a 6x and a 1x, right? Now, obviously, we know the last two numbers are going to multiply to 1. Now, this could be +1 and +1, or -1 and -1, right? But since my middle term is positive, I think you can agree that they both have to be positive because they are going to add to give you a positive 5x, right? So when you have the last number is positive, you're looking for the sum, the addition of your inner and your outer. Okay, and you say, all right, well, which inner and outer product are going to give me a 5x. And then hopefully you can see that this is your answer, and that would not work. So that is kind of like some of the idea. I mean, we could use the box method and diamond method and AC method and grouping. There's so many different ways to go ahead and technically do it. But I've found that it's very difficult. Like a lot of times they can make sense. And like when you have a hard factoring problem, it's very nice to like work through some of those methods. But in general, I think they handicap students a lot when we need to work through problems rather quickly. And it really kind of depends on what you're really trying to achieve. I think when you're first learning, it's nice to have some of those techniques. Obviously, once you get into a little bit more upper level math where you have to be able to do the factoring rather quickly, I think it's just helpful to have that that knowledge in your numeracy to be able to identify the factors by grouping, just kind of doing some of that math in your head. All right. Question number 2 says, given the rational function, it's fine, and what is the value of x is undefined? And this is from Andy. Well, so in this example, our x value is going to be undefined when our variable is equal to 0. So all we simply need to do is take our denominator, set it equal 0, and then solve. So we say when x equals 5, my denominator, that's going to equal 0, right? So when x equals 5, my function is going to be undefined. So just remember that, you cannot divide by 0. So what we want to do is find the values that make my denominator equal to 0. Question number 3, he says, I used to love math, but this year has made me come to hate it. What do I do? And I totally get it. I love teaching. And sometimes, a lot of times I walk into the classroom, like students, I can't see their facial expressions. They can't see me, right? Or when we were behind a computer and we were teaching, it was like, this isn't fun. I don't enjoy this, and I know students were saying the exact same things. It's very difficult for me to kind of give you something I feel is really going to be helpful to you. I think, I think you got to understand the situation that we're in. Some of the things that I talked about at the beginning of the year, everybody's trying to do their best, as best we can, I guess. Nobody really knows what they're doing, right? I mean, we've not gone through this before. So it's a lot of trial and error. And it's one of those things that I also, gave some advice, just make the best out of it. And I know might not be the greatest advice in the world, but it's I think it's all true. I mean, we've never been through this before. We don't really know what we're doing. And I think the best that you can do is just just do the best you can do with what you have, and then just try to make the best out of it, because I mean, this will pass, right? I mean, we're eventually going to move on to something else. You are going to, go to, move on to the next year and to the next grade and school or whatever. But, I think we just want to look back on it and be like, hey, I gave everything I could with what I had, and whatever my circumstance was. And then, I took advantage of any opportunities or experiences to enjoy, and cause I don't think there's a way to get around it. Teaching behind a computer is not fun. Learning behind a computer is not fun. Going inside of a classroom wearing a mask is not fun, So, there's not an easy way to kind of respond to this question. But I think just understanding where you are and just being realistic with it and making the most out of it is really all you can really do. And I also think that's the way we're just going to be able to get by, and work with each other and help each other. Because I mean, everybody's going through a lot. And some people have it, better than others. And some people have been experienced, more hardship than others. But, I think just understanding that and, being grateful for what you have, no matter what. And, and keep on moving forward, kind of like that procrastination, taking that step forward and moving on, because it will pass and we will move on to better things. And not to dwell on why, this has been a bad year or why you're not liking it or everything else. It's totally understandable. So, all right. So this next question came into how to solve right triangles or special right triangles. And that's for a 45-45-90 and a 30-60-90. I get this asked question actually twice in this live stream. So one thing actually, you know what I'll do is this one I'm going to answer it directly, and the other one I'll do a little bit more detailed. So in this example, I'm just going to kind of go through the understanding for the 45-45-90, because I think a lot of times when students see numbers, they get confused. So, or actually maybe in variables, but I just want you to understand when you have a 45-45-90 triangle, this is what we call an isosceles, right? So if that's 45, that's 45, that means these two angles are going to be the same. Now, if you do the Pythagorean theorem, right? X squared plus X squared, let's call this C, equals C squared. Well, what you're going to get is X times the square root of 2, right? Just doing the Pythagorean theorem. Now, when you have a 30-60-90 triangle, that's not as easy to do it. I will kind of explain where the relationship of our sides come from. But in a 30-60-90, we have a relationship with our side lengths just like we had for the 45-45-90. Now, again, noticing I'm using X as a relationship, but it could be 5. If this is 5, that's 5. This would be 5 square root of 2. But so for a 30-60-90, just to kind of give you the answer, the hypotenuse, let's call the short leg. So we have the hypotenuse, short leg, and long leg. So if the short leg's X, then the hypotenuse is going to be 2x. And the long leg is just going to be x times the square root of 3. And I'll talk a little bit more about that in the other time I address the special right triangles. Just kind of showing you where these values come from rather than like, oh yeah, that's just what he said, which is a lot of times. Oh, and actually, so the student said like how to solve right triangles. So he didn't say like understand them. So what I would basically do is the nice thing when you have a 45, you should know that these are isosceles. So if you have one side, the other side's equal to it. And then if you have the hypotenuse, just multiply by the square root of 2. That's it. Now, it does get tricky though. Like, what if I give you the hypotenuse? How do you find the leg? Well, in that case, you're going to divide by the square root of 2. And the same thing works here. Like over here, you're going to multiply by 2. To go over here, you're going to multiply by the square root of 3, right? If you have the short leg, multiply by the square root of 2 to get the hypotenuse, multiply by the square root of 3 to get the long leg. But that works the other way too. Like if I have the hypotenuse and I want to find the short leg, you're going to divide by 2. If I have the short leg, if I have the long leg and I want to find the short leg, I'm going to divide by the square root of 3. So it's just like that opposite direction. So you kind of need to know what you have and where you're trying to go. All right, question number 5. The solving. They didn't ask for how to solve this, so I'm just going to say on the interval 0 to 2 pi. All right, so first thing I would do is I'd factor out a cosecant square root of x, and that would give me a cosecant square root of x minus a 4. Equals 0. Then you can go ahead and use the zero product property. So you can say cosecant square root of x equals 0, and you can say cosecant square root of x minus 4 is equal to 0. Cosecant square root of x equals, add the 4 to the other side. That's going to equal 4, and then you would undo the square root. Kind of running out some space. Oh no, what happened? Oh, that's annoying. All right, we'll just finish this and do it myself. So what do we have? Cosecant square root of x equals 4. Then take the square root of both sides, and we get the cosecant of x equals plus or minus 2. Okay, so now what do we do here? Because then this is going to be cosecant of x equals 0. Now, like for the unit circle, you might be like, I don't understand the cosecant on the unit circle. I'm used to sine, cosine, tangent. But remember, you can deal with these as far as the reciprocals as well. So if your cosecant of x is equal to 0, well, that's going to be when the sine of x is equal to 1 over 0, or it's going to be undefined. Well, the sine of x is not going to be undefined, right? So the cosecant of x dealing with sine is not going to be undefined variable because sine represents those y coordinates. Now, if you're looking at the cosecant of x, this can be represented as the sine of x is going to equal although cosecant is equal to 0, we actually don't need to represent that. That actually might be confusing. Because I think we can still solve for that. Cosecant is equal to 0. That's actually a wrong explanation in my opinion. Because what I'm doing over here is I'm going to do plus or minus 1/2, right? Because I'm basically just going to take the reciprocal of this. But here we don't need to. We can say cosecant is equal to 0. That is going to be, actually, no, never mind. That's all right. Because if you look at cosecant is equal to 0, it's never equal to 0 because that would be when the sine of x is equal to 1 over 0, right? So that means it's undefined, which doesn't work. So when is the sine of x equal to plus or minus 1/2? Well, let's see here. That's going to be here. This is when the y coordinate is equal to 1/2. And if you were to find the values between 0 and 2 pi, that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Well, hey, Braden, thank you for joining. So question number 6, I believe this was Janeri was asking for writing the equation of a circle. I believe that's what it was. So a nice thing about a circle is we have HK, which is going to be our center. And then with this point, we have XY. Now, again, the equation for a circle is going to be x minus h squared plus y minus k squared equals r squared. Now, the thing is we have h and k, which represent our vertex, and we have x and y, right, which represent any point that goes through our circle. But we don't have r. Well, the nice thing is we can plug in these values and then solve for our r, which represents our radius. So all I'm simply going to do here is plug in my 4 minus h, 2, okay, squared, plus y, which is negative 3, minus k, squared equals r squared. All right, so 4 minus 2 is 2. 2 squared is 4. Negative 3 minus 1 is negative 4. Negative 4 squared is going to be 16 equals r squared. So therefore 20 equals r squared. And then you could say r equals the square root of 20, which is also going to equal to 2 square root of 5. Okay, so you can leave it as square root of 20, probably fine. But if you had a simplified answer, hopefully that helps you out. You want to use synthetic division. Ooh. Yeah. Oh, yeah. Ooh. Yeah, synthetic division would be, Mohammed, that would probably be a good one for that. Actually, we have 3 special right triangle ones. So kind of going back into, this is from Sigrid, as far as going back into what we did cover before. So now we have 45, 45, 90 triangle, right? So we want to find x and y. Well, again, once we know this is 45 degrees and this is 90, I can't remember the original question, but if that's 45 and that's 90, then we know A has to equal 45 degrees. And if we know A is equal to 45 degrees, then we know these two side lengths are equal to each other. So x is equal to 8. And then we can know y is just going to be the leg times the square root of 2. So that'd be 8 times the square root of 2. Done. Question number 8 says, I want more explanation regarding trig function equations and graphing it with transformations, especially for the tangent and cotangent. So a couple different ways to do this in order to understand this. I'll just kind of talk about tangent. So first thing, you need to know what the parent graph looks like. And to understand the parent graph, you need to know, the tangent, or cotangent. So let's just kind of go through some of these answers. Y over 0, 0 over 1, negative 1, 0, and 0, negative 1. Right? These are points on the unit circle that you should be familiar with. So if I said y equals tan of x, all right, now remember tangent is y over x, right? So if you recall, let's go through at 0. Well, when I take 0 over 1, that's going to give me 0. Good. What about when I go to pi halves, right? That's going to be 1 over 0. Well, that's going to be undefined, right? So if I could say pi halves, that's undefined. And obviously you can keep on going like the pi, and that's going to be that's 0 as well, right? And then you could do 3 pi over 2, which again is going to be undefined. Interesting. And then if you went negative pi halves, that's going to take you there, and then you have negative pi. All right, now, obviously we need to figure out some other angle here, and let's go and take pi fourths. So if I do pi over 4, right, that's going to be 1. And if you did negative pi over 4, that'd be a negative 1. So obviously you have these asymptotes. You know that's where the graph is going to approach. So the graph is going to look something like this, right? Now, so this graph repeats, right, indefinitely in both directions. The next thing I can just tell you for the from there, so that's how you understand the graph. But you also asked about transformations. And the best thing I can tell you about the transformations is the transformations for a quadratic, a times x minus h, quantity squared plus k, these are going to be the exact same transformations that you're going to have for tangent, right? Now, sometimes we might switch up the letters, right, to use that. Or we might use b and c and d and everything, or b in this case. But I just want you to understand, the transformations are going to be exactly the same. A is going to be vertically stretching or compressing your graph. H and C are going to be horizontally shifting your graph left and right. And K and D are going to be vertically shifting your graph up and down. Now, I didn't include the B, but B is typically going to be a coefficient of X here. And that's going to be your horizontal compression or stretch. But just to kind of keep things rather simple, I'm just excluding B in this case. But the transformations for your quadratic are going to be the exact same transformations for your tangent. Now, obviously, you also have different vocabulary that comes with tangent than your quadratic or other functions. But yeah, just make sure you kind of go back through there. Now would you be able to answer? If you submitted a question, I have 18 questions that I went through, but I had over 60 questions that were submitted. So I'm not going to be able to get to every single question. from on there. So I do appreciate the follow-up. I would just make sure that a lot of questions I did not submit or did not correct. I didn't know what the question was. Not everything I could go ahead and cover in this time period. And yeah, a lot of people submitted word problems or problems that were going to take too long for me to answer. So I just wasn't able to cover it on the live stream. Like, I can't cover everything, of course. But I was trying to do my best, and we're just about halfway done. So hopefully I'll be able to get to your questions. I'm not sure. I don't remember writing your name, so I'm not sure if you wrote your name. And that doesn't really matter. It's not required. But I just don't remember your question that you submitted. All right. But also, I forgot to mention to you guys, if you are interested, also just a reminder, guys, you can always go ahead and take a look or submit your questions onto the Discord server, where you can also go ahead and get help with your math from people just like you that are there to help and explain math, as well as you can help other people with their math and get a little bit better, better with your math that way as well. All right, so question number 9 says triangle ABC shown below has an area of 15 millimeters squared. Side AC has a length of 6. AC. Oh, okay, yeah. And BAC is an obtuse angle. Find the angle, find the length of BC. All right, so one thing I noticed here is if this is my angle A, I know that the area of a triangle is equal to 1/2. Let's see, B times C times the sine of A, okay? So that is the area formula. So if I already know this is 15 and I know my B and my C, so I'm not going to solve this question because this is going to take a little bit more for me to be able to do. What I would do though is I'd solve for A, right? So A is going to equal the sine inverse of whatever it may be, right? So you multiply by 30. C. Why didn't I write in C? 8. Okay. So what is that? 48. 48, so that's going to be what, 24? So it'd be 15 divided by 24. Okay, so then once you solve A, then you're going to want to use the law of cosines. Okay, so with A, then use the law of cosines. So then what you'll have is going to be, that's going to be your angle A. You're going to want to put A. So it'd be A squared is equal to, you'll have what? B squared plus C squared. Crap, I forgot it. Minus 2 times B times C times the cosine of A, right? So then take this angle, plug it into there, plus your B and your C, and then you can solve for A squared. And that's how you'd find that. But I'm just a little bit tight on time, so I had to finish it from there. Question number 10. Samir was asking how to solve this question. So the cool thing about a triangle is if you, we actually did a really cool problem today in my other class, but just to kind of get to the point, I guess I would say with this one is remember all the angles in a triangle are always add up to 180. So all you simply need to do is 31 degrees plus 71 degrees plus A is equal to 180 degrees. Okay. And what was that question? Oh yeah, we looked at like parallel lines and like how they add up to make a line, and it was a nice problem. So if I combine these, so that's going to give me 102 plus A equals 180 degrees. So subtract 102. You could say A is going to equal a 78 degrees. King Christian, do you struggle in math? Yes, I do. Check out some of my videos. I definitely talk about my struggle for sure. That I had learning math, but yes, that was definitely me. And hey, Gons, good to see you on. What index by 1 means? I'm not sure where you're referring to. I've never been in middle school in Colorado. I don't know. I'm looking for you guys on the score update on the Super Bowl. Maybe once I'm done, I'll go ahead and check the game. So Evan Plays asked about completing the square. It's a process. It is a confusing process. It is a lot. The best thing I can tell you with completing the square is what we want to do is create a binomial squared, right? So when we have a binomial squared, we can factor that. okay? And then we can rewrite it as a binomial squared. That is good. We like that. That's helpful. That gives us what we call in the vertex form, or that allows us to solve using inverse operations, okay? So in this, you can see this is not a perfect square trinomial. So what I'm going to do is I'm going to say, you know what? Then forget about this -5. What number do I need to add to this to make it a perfect square trinomial? Well, hopefully you see this is like a 4. Now, hopefully you guys know you just can't like randomly add a 4, right, into a problem. Like if this was equal to 0 or equal to y, you just can't add a 4. If you're going to add a 4, then you're going to have to subtract the 4 or add the 4 to both sides, whatever works. But now we know that x squared plus 4x plus 4, that can just be written as x plus 2 quantity squared. And then if you -5 minus 4, it's just going to be a -9. Okay. And there you go. That's complete square. Now, if you needed to solve the set equals 0, you can add 9 to square root, and then subtract 2, or this would also be in your vertex form. All right. Angle, side angle, and side angle, side angle. Oh yeah, and also just a reminder, guys, submit the questions. I know a lot of people keep on adding, for your questions. Remember, guys, you can submit your questions in the Google form, or actually I have an extra link in the form, as well as my Discord server in the form of description of this. I always forget to keep on adding that. I got to do that at the beginning of the video. So, but it's a good thing to just kind of keep on remembering. The question number 12. So angle, side angle, side postulates. I'm not really sure where to do with this one. I guess if you have two triangles, all right, and so let's look at these two triangles. Now let's say we don't know what these two triangles look like, okay? So what I'm going to do, okay, now let's actually delete that and delete that. No, crap. All right, let me do them a little bit again. Okay, let's make these a little bit bigger. Okay. So let's say we have angle, angle, right? Side, side. So these are all preserved, right? Well, I want you to see, like, there's no other way. Like, this has to prove congruency. Angle, side, angle, angle, side, angle. Now, I don't know what this triangle is going to look like. Let's pretend, right? We don't know what it's going to look like. But hopefully you understand, if this angle is preserved, and this angle is preserved, and this side length is preserved, the only triangle that this is going to produce is going to be exactly the same as that. So I could do the same thing for side, for angle side, or for side angle side. They all prove congruency, just like side side side, angle side angle, side angle side. You could do angle angle side, right? And then you could do side side angle, HL, right? But those all prove congruency because there is no other way for you to be able to. As long as you have that much of information, the two triangles are going to be congruent. So I'm not really sure what your trouble is with the postulates, or if it was just visualizing why they work or they are applied. Question number 13, you can see, like, here's a question where I'm like, a lot of these I just kind of like, I'm just not able to go through each and every one of these, like, multiple questions inside of one. But I will take the first one from here, which is a composition of f of g of big G of x. Okay, so let's see here. We got f of x equals absolute value of x. And a lot of people submitted multiple questions tonight. I'm not really sure why that was the case, but like multiple questions or like worksheets. I'm like, guys, I just don't have time to do all that. I try to do my best, but that's a lot of problems. And I got school tomorrow and I got to do more math to that. So, and I did math this weekend. So I was recording more videos yesterday. And then on Friday, I was recording videos and okay, craziness. So what does this composition mean? Like, what does this notation mean? Well, what this notation means, guys, is we're just going to take f of g of big G of x. Okay, so what we're going to be doing is we're going to take our g of x function and we're going to plug it into the little g of x function. And thank you so much, Daniel, for submitting your super chat. I very do appreciate it. And again, you added questions to your super chat, so now I cannot avoid your questions. So thank you so much. I really do appreciate that. So I'm going to have to take a break. Sorry about that. How difficult do you find linear algebra? By the way, you're your best friend. Well, thank you so much. I struggled with my linear algebra class, and I think part of it was my professor that I had. I've learned some linear algebra after I took that course, and it became a little bit easier than what I remember being inside the classroom. So I think a lot of it was the professor that I had, because I took math way past linear algebra in college, and I didn't have as many difficulties that I had in that class. But also could have been the course, just the kind of the rigor of that course, maybe something I wasn't planning or expecting. But I don't think overall the course is, based like looking back on linear algebra in the spectrum that of all the other courses, it wasn't anything crazy that I don't think that I should have struggled with as much as I did as far as the content or what was, required of me. So I think it was just a lot of, the semester that I was taking. I don't remember what other courses I was taking, the professor that I had. I just don't think things added up for me as much as they probably could have or should have. But I think you can definitely, if you're at that point, just put, I think you can definitely, make it through there. All right. So in this example, we have f of g of x. So what we're going to do is we're going to take our g of x function and we're going to plug it into the fx, right? So this basically equals f of g of, well, let's figure out what's big G of x. That's going to be a 1 over x squared, right? Or I'm sorry, 1 over x minus 2, right? Well, again, what is 1 over x minus 2 into our little g of x function? So basically, we're going to take this, right, and plug it into there. So that's equal to an f of 1 over x minus 2 squared minus 4, right? So all I'm doing is I keep on plugging this into my g of x function. And now I'm going to take this and I'm going to plug it into my fx function, which is the absolute value function. So that's going to be a absolute value of 1 minus x minus 2 quine squared minus 4. Okay. All right. I only got 2 more minutes left. I'm supposed to go on a live stream with the YouTube members to answer a question. So I'll try to answer that, but I might be a little late. So let's try to go through this. Describe inverse operations, inverse function steps. All right. So this is not written as a function or an equation, so I'm going to do that. Basically, all we simply want to do when we're finding the inverse, swap our variables. That's a y. No, that's an x. Yeah, all right. So we have x equals a negative y plus 3 cubed. Okay, and then we're going to use our inverse operations. So we're going to take the cube root of both sides. So we have the cube root of x equals cube root of function squared, so that's negative y plus 3, divide by negative 1, so we have a negative cube root of x equals a y plus 3, and then I can just write this as a y inverse of a negative y inverse equals negative 3 minus a cube root of x. All right, there you go. Question number 15, can you upload a video about discussing how to take math notes? I don't know why I took this down, Gabby, because I think as far as your math notes, there's a couple things, I guess there's maybe some things I was thinking about, like his math notes. I think the number one thing is, I think your attention needs to take precedent. Like when you're learning math, you should hopefully have some notes. Like I give my students their notes printed ahead of class because I want them to review them and I want them to be available. I don't want them to be rushing, like trying to write things down while we're learning in class. So I think the number one thing is you should have some kind of system or process where you can have as much of the information and notes completed or prepared ahead of time. So therefore you can just be present. Like when you're learning math, I think you need to like have full focus, especially if math is even like a difficult topic for you, and so having that attention, so you're not, spending your time writing down equations, formulas, theorems, and then your teacher is explaining why this works or why that makes sense. You don't want to put yourself in that position. I will just be 5 minutes late, but I'll add that stream. So I think that for number one. And then I think for number two is right, just, writing down as many examples and doing like a cheat sheet, going back through your notes and writing down the most important information. And, doing that, I remember a lot of times I would, a lot of classes where I was taking frivolous notes, I would rewrite my notes, rewrite them 2 or 3 times. So rewrite the notes from class. So what I mean by rewrite them is I take my notes down, right? And let's say these are ones I couldn't have prepared. So I would just write down the notes as fast as I could, right? And then what I do is I rewrite them so they're nice and clean and I could understand them and just to reflect on them. And then I'd rewrite them again prior to my test to just kind of organize them and really, again, this understand what was going on in that class. And a lot of times every single time I rewrote them, it just kind of made a little bit more and more sense. All right, question number 16. So, find these values. How do we know these values are what they are? So I think it's important to understand that when you are dealing with a 45, 45, 90 triangle, to understand a 45, 45, 90 triangle, 45, 45, 90 triangle. Oh yeah, right. So if we had, this is going to be there we go. 45. Yeah, what I miss in my definitions? How did I make this? Yeah, I guess if this is, I'm sorry, I'm going through this. So if we know this is 90 and we know this is 45 and that's 45, I kind of already explained this in the other one. I guess that's why I was confusing myself. Then we know these are isosceles, right? So they're the same. And then, so no matter what the value is, that's x, that's x. So when you do the Pythagorean theorem, you're going to get s times the square root of 2, always. Now on the 3690, we can understand this by looking at a equilateral triangle where all the sides are the same, right? So let's just call the sides x. Now, if I create a angle bisector that's perpendicular here with this base, then that's going to be x divided by 2, right? So the hypotenuse, and that's going to be x divided by 2. That's going to be an angle bisector, so that's going to make that 30 degrees. Then if you use the Pythagorean theorem, again, you're going to get you are going to get a x divided by 2 times the square root of 3. And that's how we get the relationship for our 30, 60, 90 triangle, is again by understanding that using the Pythagorean theorem to go from there. So hopefully that kind of explains it. I mean, this is the 3rd time that I kind of went over this, at least in this live stream. So hopefully that kind of at least helps where these values, where this relationship comes from. All right, question number 4 talks about the exterior angles. So the cool thing about exterior angles, so we talked about the interior angles. And I think when you're talking about exterior angles, it's very important to understand that you can create a linear pair, right? And every single time you understand that linear pair, especially for a triangle, you realize that, hey, all these angles add up to, and again, you could do it with protractor, you can do it with whatever angles. If you have the angles in a triangle, find the supplement of each of those angles. And what you'll find out is all the exterior angles add up to 360. And let's look at one that's very easy. Let's look at a rectangle or a square, right? If we know these are all 90, right? Well, then these are all going to be 90, which again add up to 360. So the important thing you need to understand here is that all the angles, doesn't matter what the shape is, if it's a rectangle, pentagon, hexagon, the larger and the more and more sides they get, the more you're getting something that's going to look like a circle, which they all add up to 360 degrees. Okay, so all I'm simply going to do is just take 100 degrees plus c plus 55 plus 55 plus 90 equals 360 degrees. All right, so let's see, that's going to be 110. So that'd be 110, so that'd be 200, so this would be 300. So c plus 300 equals 360. And then subtract 300. And then c equals 60 degrees. And voila. All right. Question number 18 says an object that is thrown downward from initial height of 25 feet can be modeled by the function h of t equals 25 plus 15t squared, where h is the distance the object travels in feet and t is the time it takes in seconds. Determine the inverse. Okay, we did that. And then determine the height of the object when t is equal to 30. Well, the cool thing for the height is where h is the distance and h is the distance. I'm assuming h is the distance the object travels in feet, which is the height. So I can just basically say h of 30, so when t equals 30, that's going to be 25 plus 15 times 30 squared. So that's going to be the second bullet. You can just figure that one out. As far as the inverse, what we're going to do is we're going to do the same thing we did before. So what would that be? 900 times 15, then plus 25, whatever that is. So as far as the second bullet point, let's just go and replace h of t with y equals 25 plus 15 t squared. Okay, so we will swap the variables. You could use x if you wanted to, but it's fine. So we'll make this a t equals 25 plus a 15y squared. Subtract 25, so we have t minus 25 equals a 15y squared, divide by 15, 1/15 over t minus 25 equals y squared. Now, we have something interesting here because we have the square root. Well, when we introduce the square root, guys, we're going to be dealing with like plus or minus, right? So my brain is not really thinking as much because this is my last question, but we can't have plus or minus. So we have to understand, like, are we dealing with the positive or the negative version of this radicand, or not the radicand, but of the square root. And I believe since we're dealing with the path of the ball, then we're going to want to, and this is going to be the, if you think about that, if you're thinking about like the path of the ball, you're only going to be worrying about the positive version, right? So that's where we're going to be looking at the positive version of, although this is weird, slow downward. That should be a negative, wouldn't it? Initial height. Something kind of seems a little off with this, because if you're throwing an object downward, that should be a negative 15t. So, not really sure what's going on with that. But I'll just finish this question from here, and I'll use the positive version instead of the negative, because it doesn't really make sense to deal with the negative version of that graph or function. Okay. All right, guys. Well, thank you so much for joining me on the live stream, especially for Super Bowl Sunday. For those of you football fans, I really did appreciate going through the questions. And again, I do apologize, guys. I got a lot of questions this week. But feel free to always be more detailed. Submit your question very specific into me for next week. The link is in the description down below. Also, you can go ahead and join the Discord server and get some questions, answer some questions, help you guys with that. And otherwise, guys, I will look forward to seeing you in the next live stream next week on Sunday, 9 p.m. All right, guys, have a great night. I'll see you then. Cheers.